In this lesson, we are starting the next unit and we are working with probability. And so we're starting with the fundamental counting principle and permutations. So we will use the fundamental counting principle to count the number of ways that an event can happen, and then we will also use permutations to be able to do the same thing. So let's take a look at a problem. If you take a look down here, where we have this problem, you have 4 choices for an appetizer, and we have 6 choices for pop, and we have 10 choices for main course, and we have 3 choices for a dessert. How many different meals can you make? If we use what's called the fundamental counting principle, and that's how we're going to find out the number of ways that we could make the different meals, we simply have to multiply how many different ways together. And we also, if we want to talk about a specific order, that's called the permutation. So let's take a look. What we're going to do is multiply. So we have 4 appetizer, we have 6 pop choices, we have 10 for the main course, and we have 3 desserts. We simply multiply those together, and that's going to tell us how many different meals we could create. That would be 720 different meal choices you could have with all of those. Let's take a look. How many ways can you arrange the letters BAD, B-A-D? Because order is going to matter and we aren't going to repeat letters, we have that there would be 3 different letters in the word that we would make up. So for the first choice, there are 3 letters in the word bad, and if I use one of them, then I'd have 2 choices left for my second position, and I'd have 1 choice left for my third position. That means there are 6 different ways that I can arrange the word bad. How about the next problem? How many different 7-digit phone numbers are possible if the first digit can't be a 0 or a 1? So I have 7 digits. And remember, there are 10 digits in our number system, 0 through 9, but it tells us that the first digit can't be a 0 or a 1, so that means I have 8 choices. Now, if I have used one of the choices of the 10 digits, that means that I have 9 left for this position. Then I have 8 left, 7, 6, 5, and so on for 4. We're using our fundamental counting principle. We simply multiply all of those together, and that's going to be 483,840 different ways that I can make up those phone numbers. Now in this case, I was making different 7-digit phone numbers. If I were to tell you that I could repeat those numbers, if there could be repeating digits, then that would be calculated differently. I'm still telling you that I can't use a 0 or a 1 for my first digit. However, if I can repeat digits, let's say I could use the number 7 here, and then I could use all 9s for the rest, then that means I would have 10 different choices to pick from if I can repeat. That's going to give us a lot more different phone numbers. 1, 2, 3, 4, 5, 6, 7 different digits. And when I multiply that together, that's going to give me 8. 1, 2, 3, 4, 5, 6, 8 million. If I can repeat. But this said how many different 7-digit phone numbers if we would take that into consideration and want different digits for each one. But if the digits could repeat, there could be 8 million of them. Let's take a look at our next slide. And we're talking about factorial. Factorial is the product of all the integers from 1 to n, and it is denoted by an exclamation point. It is read as n factorial. There are a couple of special cases. 0 factorial is 1. 1 factorial is 1. 4 factorial simply means 4 times 3 times 2 times 1. And that's going to be 24. And then if we have 7 factorial, that's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1, and that equals 5,040. Now, what I would like you to do is to take a look at your graphing calculator, and under the math menu, if you arrow over to probability, PRB, you'll notice in that section there is a factorial button, so that you could use that also to calculate without having to write everything out. Now we'll take a look at permutations. Permutation is what you can use when you want to order objects. So in general, the number of permutations of n distinct objects is n factorial. Remember again that our special cases are 0 factorial is 1 and 1 factorial is 1. So let's take a look at a couple of problems. So on this particular one, when we're taking a look at if I want to order 7 distinct objects 3 at a time, that means that I want to have only 3 of them. And if I use the fundamental counting principle, I'm going to take my 7 different objects, and if I select one of them, I'll have 6 left for my next. And if I select one, I'll have 5 left. So if I use the fundamental counting principle, it tells me that there would be 210 different arrangements. If I use the permutation rule, I can do it in a different way because this fundamental counting principle can become very tedious for large situations. So this is the rule, and what it says is n is the number of objects that I have, and r is how many did I select. So number that I have, how many did I select is the r. And we calculate it this way. N factorial, the number that I have would be 7 factorial divided by n factorial minus r factorial, which would be 7 minus 3 factorial. Now, if we are to work that out, this is the way it goes. So we have 7 factorial divided by 4 factorial. Now we could use our calculator, but I do want you to show your work on this. So 7 factorial means 7 times 6 times 5 times 4 factorial, or 4321. And then we have on the bottom, we have 4 factorial. So notice I could put 4321 on the bottom, 4321 on the top. But once you get 4 factorial on the bottom and 4 factorial on the top, those can simplify. So we have 7 times 6 times 5, which gives us our same answer of 210 different ways that we can arrange those objects to get 3 at a time. So we can use the fundamental counting principle, or we can use the permutation. And the permutation is much better for larger situations that are more tedious. So, there are 8 movies you would like to see currently showing in theaters. In how many different ways can you see all 8 of those movies? Well, we can do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is how we can use the fundamental counting principle, or we can use our permutation. And what the permutation says is I have 8 choices and I want to pick all 8 of those. So here's how it works. We have 8 factorial divided by 8 minus 8 factorial, which is 8 factorial divided by 0 factorial. And we know that 0 factorial is 1. So if you plug 8 factorial into your calculator, remember you press the 8, then the math button, arrow over to probability, and then select factorial. That's going to come out to be 40,320 different ways that I can see those movies. In letter B, it says how many ways can you choose a movie to see Saturday and 1 on Sunday? Well, if there are 8 movies, I can see 1 of those movies on Saturday, and once I've watched one of those, I have 7 choices left for Sunday. That would be 56 different ways I can see the movie using the fundamental counting principle. Because it is a very small problem, you might want to do it this way. But you can also use permutation. So I have 8 movies and I'm going to select 2 of them. So I have 8 factorial divided by 8 minus 2 factorial. That gives me 8 factorial divided by 6 factorial. And then when we work that out, we have 8 factorial is 8 times 7 times 6 factorial divided by 6 factorial. So we have 6 factorial divided by 6 factorial is 1. So that's going to give us 56 different ways that we could watch the movies on Saturday and on Sunday. Okay, now the next thing we need to talk about is what happens if objects are not distinct. In other words, they're repeated. For example, the word pop, P-O-P. How many different ways can I arrange the letters of pop, P-O-P, and to get to have distinguishable patterns, that they do not have the same ones? So the way that it works is there are 3 letters, 3 choices. So that's going to be 3 factorial. And we divide that by how many different letters and what they repeat. So I have 1 letter, but that letter is repeating twice. So I'm dividing it by 2 factorial. So that's 3 factorial divided by 2 factorial. And the 3 factorial, remember, is 3 times 2 times 1, which is 3 times 2 factorial, and the 2 factorial will simplify. So that's going to give us 3 different arrangements that are distinct. Okay? So make sure you're aware of whether the problem asks you for repetition or no repetition. Let's take a look at an example. So I have the word summer. It says find the number of distinguishable permutations of the letters, which means they can't be the same pattern. So in the word summer, there are 6 letters, and there is 1 letter, the M repeats. And how many M's are there? There are 2 of them, so that's going to be 2 factorial. So when we calculate that, we have 6 times 5 times 4 times 3 times 2 factorial. And that's going to be divided by 2 factorial. So we'll cancel or simplify that. So we have 6 times 5 times 4 times 3, which means there are 360 different ways that I can make distinguishable permutations of the letters of summer. Let's take a look at the word bananas. So in the word bananas, there are 7 letters in the word banana. And then we do have some repeats. So in the word banana, we have 1, 2, 3 A's. So the letter A, there are 3 of them. That's going to be 3 factorial. And we have 2 N's. So that's going to be 2 factorial. So when we write that out, we can either write this all the way out and simplify like in the word summer, or if you would like to use your calculator, you can take 7 factorial, so press the number 7, the math button, go over to probability to find your factorial, and then divide that by, and make sure when you are doing this that you put the denominator in parentheses, 3 factorial times 2 factorial. This is going to give us 420 distinguishable permutations of the letters in the word bananas. One more example. A music store wants to display 3 identical keyboards, 2 identical trumpets, and 2 identical guitars. That means there are 7 items that they want to display. But because we want distinguishable, we want to take out those repeaters. So there are 3 keyboards, 2 trumpets, and 2 guitars. If we plug that into our calculator, again making sure that when you do the denominator you put that section into parentheses, that's going to give us 210 distinguishable displays. So to review, make sure you know that we're working with the fundamental counting principle, where we can simply multiply the items together to get the total number of ways. Permutation is an ordering of objects. Order does matter. If we have repetitions and we want distinguishable permutations, we're going to take the number of items and divide it by the repetitions. And we can also use permutations instead of the fundamental counting principle to find our ways, which is better when we have a larger amount of items.